Alright, let's try and live solve this question in the last 25 minutes. I mean, I've never seen this question before. Most people weren't worried about this question, so this is just kind of a bonus for us. Maybe it's the kind of question I've noticed a lot of these question ones make pretty good AIMO practice questions as well. The only difference is you need to write a proof. So what is the question? Determine all triples ABN of positive integers that satisfy this equation. Does that make sense? Okay, Finn makes the first observation that B is even. Why is that? Okay, so I agree with some of this. So let's be a bit rigorous. So 2 to the A is even, right? Because A is greater than 0. Yeah? Oh, and it's an integer. So B is only even if n, so if n factorial is mostly even, yeah? So n factorial is even if n is bigger than or equal to 2, yeah? But it's actually equal to 1 if n equals 1. So maybe we could deal with that case separately. So what if n was 1? If n was 1, oh,
15.
15. 15 is supposed to equal the power of 2 plus a square. That. How do we solve that?
Because if we know 2 to the A is going to be even, the square has to be on. And then.
Yeah, we can be a bit more direct. Yeah, so I mean 1, 4, 9, but only really 1 and 9. Yeah.
Yeah.
So 14 is not a power of 2, and 6 is not a power of 2. Yeah. And there's no other squares. Yeah. Okay, so we have that there's no solutions with n equals 1, yeah? Okay, well that's good. And then the rest is like, I guess, you know, B is even. So now if n is greater than 1. With the easier questions, I tend to want to like use my rough working. I want to recycle it as the solution because I can't be bothered to write it again. But maybe these are not pure habits. No, you can't have 0, yeah. It's in positive integers. So you have B is even. Okay. Huh. You got a square, a power of 2, and a factorial. What a craziness.
Two, right? 16. Squared divided 4.
I think I see it, but I don't want to give it away. Wait, you said something interesting. What did you say? You said something, what did you say? Multiple of 4? I heard things that triggered my interesting response.
Yeah.
Okay, is Finn suggesting 2, 4, 3 is a solution? Let's see, 2, 4, 3. What, you mean B is 4 or B is 2? B is 4. Okay, let's try this. So 16 plus 4 is 20. And 20 is it 3 factorial plus 14? It is, yeah? We have a solution.
Nice.
Nice. How does that work? N is 3. Oh, I see how that works. 4, 2, 3 also works. Wow. 4, 2, 3. So 4, 2, 3 means 16 plus 4. Oh, it's the same, but the other way around. Yes. Oh, okay. Alright, well, I'll send you the recording, Finn. Please still.
Wait.
So you heard me say something about a multiple of 4. You said that was interesting. So therefore,
Yeah. What is it?
does it only work with multiple? Like, and factorial plus.
Well, I mean, so one of the things you might notice, like when you say b is even, right? Like because it's being squared, right? That evenness is gonna compound, so it's gonna be a multiple of 4 when you square it, right? And I mean, powers of 2 are probably gonna be multiples of 4, yeah? And n factorials are usually multiples of 4, yeah? But 14 is not a multiple of 4. So
Yeah.
that's a big no-no.
So you should make that so that when you add over 14, it's
Yeah, so you can see why those solutions work, right? Because 3 factorial only has one, it's not a multiple of 4, so 3 can add with the 7 to make a multiple of 4.
but then from then on, it will always be.
Yeah, so it works. But see, if you get n equals 4, it won't work unless something, something, something.
But then, if it's like that, and as soon as it has a multiple of 4, it goes on. Then wouldn't everything else over.
Basically, so you gotta say this. Okay, let's say this. What happens if n is greater than 3? Yeah. Hmm. Okay, let me start typing this then. Okay. So if we have n equals 1, get 2 to the a plus b squared equals 15.
Well,
This. There is one to film like this.
Okay, n equals 2 to the a plus b squared. I'll do n equals greater than 3. It seems to be more systematic to do n equals 2 next. Yeah, I mean, certain variants of these problems, like power of 2 equals some factorial plus some number, they're unsolved problems. It's just funny when you put certain numbers in, those unsolved problems become really easy questions. Okay, so if n equals 2, then this is just 16, right? So you could try, so it's going to be even again. It's going to be even now, so it's only 2 or 2 squared is 4. 4 squared is 16. Again, no solutions. Suppose n is greater than 3, huh? If n is greater than 3, then 4 divides n factorial, yeah? B is even, so that means 4 divides b squared, right? Um, but 4 does not divide 14, yeah? Therefore, a has to be 1, right? Which is quite telling, okay? So that means 2 plus b squared equals n factorial plus 14, right? Where do I write that? Right there, here, yeah? That's the thing we're trying to solve now. Oh, that means b squared equals n factorial plus 12, yeah? Okay, so we simplified it. If n is bigger than 3, b squared equals n factorial plus 12, you know? Okay. Okay, so how do we solve these problems? So one thing I would try to do, since we're on this train of thought, we only have 10 minutes, guys. So if we take the 4 out of 12, you get 3, right?
Yeah.
And you can take the 4 out of n factorial, you get something, yeah? And if you take the 4 out of b squared, you get b over 2 squared, yeah? Yeah? Can you see there's something not quite right about this equation?
Wait, where did the blue come from?
I divide the 12 by 4. Divided both sides by 4.
So,
Something not quite right with that equation.
what happened to the 2 to the A?
Oh, the 2 to the A has to be 1. The 2 to the A just became 2. See? If you look at this.
Ah, okay.
The 2 to the A becomes 2, and then 2 goes to 12 when you minus from 14. Okay. So then b over 2 squared equals n factorial 4 plus 3, right? That's what we have. So I can erase this now. You see that? So b on 2 squared. So b is even, so b on 2 is still an integer. Okay? N factorial is divisible by 4, so n factorial on 4 is still an integer. You know? You see anything wrong with this equation? So let me just give you a hint. If you look at mod 4, okay? Mod 4 is 0, 1, 2, 3, yeah? If you square them, you get 0, 1, 0, 1, right?
Yeah.
Okay. You see how that relates to what we're doing? So basically,
Over 0.
if you square stuff mod 4, you only get 0 and 1, right? You don't get 3, yeah? So if you take this equation mod 4, yeah, then basically, because this is a square, right? Yeah. If this number is divisible by 4, then this square is equal to 3 mod 4, right? See that? So if n factorial of 4 is divisible by 4, yeah, then b on 2 squared equals 3 mod 4, yeah?
Then b on 2 squared is b squared on 4.
Oh, no, it's the whole point is something squared equals 3 mod 4, right? So that something happens to be b on 2, but we don't really care about that. We just mainly care something squared equals 3 mod 4, yeah? But nothing squares to 3 mod 4, right?
Oh.
Okay. So that means that you can't have n factorial on 4 be divisible by 4, you know? Does that make sense? Since there are no squares congruent to 3 mod 4, n factorial on 4 must not be divisible by 4, yeah? Okay, so can you explain to me how n factorial could not be divisible by 4? What ways can n factorial on 4 not be divisible by 4? Like if n factorial on 4 is not divisible by 4, yeah? What can we say about n?
N is below below
4 factorial.
is three less than or equal to 3.
No.
Because if it's like n
Like you're dividing by 4, right?
yeah.
So you're getting rid of 4 and then you're saying it's got no more 4s in it. So it could have had 4. You could even have 8, yeah? So for example, like 5 factorial, yeah? That's
Get rid of the
that's
4.
got a 4 and a 2, right? Once you get rid of the 4, it's got only a 2. So 5 factorial is not divisible by 4, yeah? once you divide it by 4. Yeah, so basically 6 factorial is the cutoff, okay? Because 6 factorial is divisible by 4 even after you divide it by 4. Because it's got the 2 from the 6 and 2 from the 2, right?
Yeah.
Okay. So this means that n must be less than or equal to 5, yeah? You see that?
Yeah.
So automatically something's kind of wrong here. Something's slightly wrong with what we're doing because we actually have some solutions, remember? Oh, all our solutions were for n is greater than 3. Okay, so we haven't actually done n equals 3 yet, yes? So we need to do n equals 3. And then we actually find some solutions. Remember all the solutions? It was like 2, 4, 2, 4, 3, 4, 2, 3. Yeah, so there's actually solutions. We should prove that they're the only ones as well. Okay, well while we're going here, n is less than or equal to 5, yeah? So because n is greater than 3, it has to be either 4 or 5, right? So it's really, now we just have n equals 4 and n equals 5, yeah?
God damn.
Okay. If any of you guys want to do this for homework, I would like to see your solutions, okay? This is kind of pointless for me doing it, right? It's kind of, like I'm not really getting any younger. I don't necessarily think it makes me even maintain my skill level at this. I just, you know, I don't know. Maybe in the last 2 minutes you can carry me through one of 3, 4, or 5, or you can do it for homework. Ooh, there's 3 of you and there's 3 cases. Who wants 4? Who wants 3? Who wants 5?
Wait, to do? What's there to do for 3?
You have to prove that those are the only solutions.
What do we do for 4?
You have to prove what the solutions are. Okay, so Daniel wants to do 4 with Finn. Is that what he's saying?
No, you're saying there's 4 people if we include Finn.
Oh yeah, there's only 3 cases. Finn already did a little bit of 3, I guess. Okay, Daniel's got 4, okay?
5.
So maybe you can type.
I guess I'm doing 3. 10, 2, 4.
So what do we do? Do we just say those?
Okay, so Martin, you're doing 3. Daniel is doing 4. And Rihanna got 5.
I like how we don't include my last name.
Wait, so what are we trying to prove?
This guy. Trying to find all the possible A, B, and N's. But N is 3, so you just have to find all the possible A, B's that make N equals 3 the equation work.
So are you sure you want me to make it really messy? I have to refresh my mind before I go. I was just asking for the betterment of society.
Actually, since Finn came up with those 2 solutions, he should probably try to finish it as well, just in case. I'll send him the video.
I think Finn will just think time.
I'm gonna do it when I get home. I'm gonna team
And then you'll just never go home.
Yeah, I'm probably gonna forget.
Endless fun, huh? It just never ends, does it?
I'm dead on the inside.
Dead on the
So,
inside.
do we have what bookmark is this fitting? I don't want to scroll through 1,000 pages.
Actually, you shouldn't try to look this up. You should just kind of write down the equation you're trying to solve.
And then
So write down 2 to the A plus B squared equals 20, basically. 2 to the a plus b squared equals 20. Okay. Should be pretty easy.
Is that it?
Yep.
Oh.
And tell me that they're the only solutions. And I will trust you according to your
So
credibility.
I don't have to write it down in Overleaf?
No.
I can just send it to you.
You can just type it on Discord. How about that?
Okay, that's great.
Yeah.
That is a good idea.
Okay, let's go, people.